Hi everyone! This video is for those of you who had a hard time hearing me in class during our first class meeting. We covered and talked about the syllabus, classroom expectations, classroom procedures, all of that can be found again in the syllabus on eCampus. And I will do my best to remind you of all of those when you guys come back to the classroom, hopefully in quarter two or sometime later on. We did move on and started looking into our Unit 0, which is all about Intro to Science and Statistics with Gummy Bears. This worksheet is in eCampus, and you were asked to follow up and complete up to, I believe, page 1 or the very beginning of page 2. Okay, so in class I mentioned how calling scientific method a scientific method is really misleading because it makes it sound like it's a bunch of steps that you have got to follow in that given order, and that's really not the case when it comes to science. So I'm proposing that we call it scientific investigation, and that makes it sound like a more fluid and more sort of changeable process, and that is the case. It typically does involve steps such as observations, researching, hypothesizing, testing, collecting data, and so much more. But again, those steps do not have to be rigid and they can vary from time to time. I'm looking at number 2 now, and it says many scientific investigations begin with unblank or a blank, and you should be thinking and responding with an observation or a question. Most of the time, investigations begin with either an observation or a question that you might have. For example, here's a question that we can look at. How does the mass of gummy bears change when soaked in different solutions? Okay, so if that is your question, you might initially research it a bit and then you can at that point continue to hypothesize as to what the answer to the question in this case could be. So let's talk about hypothesizing. There's two types of hypothesis to be aware of: null hypothesis and the alternate hypothesis. The null hypothesis is one that claims that there is simply no correlation between the variables in a given scenario. So in this case, we're saying that the mass of gummy bears is simply not affected by whatever solution they're soaked in. And then we have the alternate hypothesis, the one that we pose with the purpose to reject the null hypothesis or to replace the null hypothesis. And this alternate hypothesis does claim correlation or some relationship between the two variables. So we're saying that one variable does affect another. So in this case with the gummy bears, we could say that the mass of gummy bears will increase or the mass of gummy bears could decrease. So we are showing correlation between the two variables. Alrighty, moving on to 5. After hypothesizing, a blank experiment is designed and performed. And the keyword there is controlled experiment. Your experiment has to be controlled. That means you keep everything the same and constant except for that one variable that you are deciding to change and test. Okay? After you make your experiment, you will likely have some data. You will collect the data, analyze it, and try to make a conclusion. Okay, oftentimes in AP Bio, you're going to be asked to design a controlled experiment, and you will have to get better at this over time. For right now, an outline that would be sufficient would be something along the lines of you saying that you would start off by massing or weighing some gummies. You can decide the number. You can do 3, 5, 10. So mass the gummies before you do anything else. Then you would probably take some cups or beakers and put the different solutions in those cups or beakers. Then you would add the gummies to these cups and beakers, leave them in there to be soaked for a given amount of time. You have to obviously specify this part. And then after, let's say, a few hours or a day or two, you will collect the gummies, mask them again, and then look at your data and try to come up with a conclusion. So that's a really rough draft of what an outline needs to look like or sound like. Let's move on to question 6, and let's look at a more specific question. The question is, do all colors of bears gain or lose the same amount of mass in the same solution? So it's a different question, so we have to analyze it and discuss it. So let's talk about what is an independent variable. An independent variable is the one that you as the experimenter are changing and you're testing in the experiment. So that one thing that you decide to test and change is the independent variable. In our scenario with this second question, the independent variable is going to be the colors of bears. That is what you are changing or manipulating at the very beginning, the colors of bears. Okay? Now let's talk about the dependent variable. This variable is the one that obviously depends on the independent variable. Okay? The one that is observed and the one that is a response to the independent variable. Okay? In our case with this question, the dependent variable is going to be the amount of mass that is gained or lost. So we're trying to see how different colors, independent variable, will behave in terms of gain or loss of mass. That's my dependent variable. You can also say the mass gain or loss will depend on the color of gummy bear. Okay, let's talk about 6E. What is a control group? A control group is a group in an experiment that does not get the treatment or the independent variable. It is left alone as is. And there's two types of control groups. There's a positive control group and a negative control group. Most of you are likely familiar with the negative kind. That is the kind that gets no treatment or gets a placebo treatment, which means a fake treatment. A positive control group is one where a treatment is given, but the results are well understood and expected. For example, let's say that a company is trying to launch a new face wash or an acne wash. A positive control group would be people who are using an acne wash that's already available and that gives a certain and known result. That will be a positive control group. Moving on to 6F. What would be a negative control group in our scenario with the gummies? You should say gummies that are unsoaked. Okay? We can also look at G and H to conclude. G says the opposite of the control group is the blank group, and you should be thinking experimental group. It differs from the control because it does have treatment applied to it. It does have the independent variable applied to it, and the control group is absolutely necessary for you to be able to compare it to the data that you get from the experimental group so you can see if the independent variable is causing a certain outcome or a response. And lastly, part H, what should be held constant to ensure that your results are valid? And the answer should be everything else but your independent variable needs to be kept constant. Temperature, time of the day, the person who's experimenting, the volume of the solutions, everything else besides that one thing needs to be held constant or controlled. Okay? I hope this was helpful.